Alright, so today we're doing inverse functions, which is section 1.9 from the book that I teach from. And so there will be two sections of notes. The first one is this kind of idea behind it, and it's just a general idea. I'm not showing any examples on here this time, but I will. So what we have is, if say fx equals x plus 4, and this is the set, 1, 5, 2, 6, 3, 7, and so on, just ordered points. The inverse function is f of negative 1, f negative 1x, so this means inverse function, okay, which would be x minus 4. I'm going to go over how you find inverse functions later. So then that set becomes 5, 1, 6, 2, 7, 3. You see they flip for the inverse functions. For the most part, they're just going to flip. There is some extra details in there, but for the most part, they do flip. Another special case, and this concept comes from section 1.8, which was composite functions, is if f of g of x, or fog, equals x, or g of f of x equals x, then the functions are inverse functions. So basically, if you plug a g into f, and after you do the math, you get x out, that means g is an inverse function of f. And vice versa, f is an inverse function of g. Another little side trick of this is f of f inverse of x equals x, and f inverse of f of x equals x. Basically, the inverse functions cancel out, so where all you're left with is the variable. So if you need to write these down, I will do that real quick while I get up the next set of notes, and then we'll do some examples. Okay. Alright, so the next set of notes is finding inverse functions. If you're in my class or have the same pre-calc book, it's on page 96. There's 5 steps. I'm only going to list 4 because I'll say what the 5th one is. I don't think it is important, but in terms of the process, it's not too important, if that makes any sense. The first one is horizontal line test. So that is like a parabola. Does not have an inverse function, because if I had a graph, I'll just draw one up real quick. If I had a graph like this, and my parabola, any standard parabola, the idea is if I draw a horizontal line, and it touches it twice, intersects it twice, so at the same y coordinate, that means there is no inverse function for that equation. So a parabola does not have an inverse function. But other certain ones will, like a square root will, because there's no horizontal line that comes through them. And I'll go through examples of how we find them. So then the second one, and this is the big part that my class, and if you're watching this, not my class, but the big part that I try to get is steps 2, 3, and 4. 2 is, we're going to have our equation. Replace the f of x with a y. Okay, so that one's a pretty easy step. The second part is so number 3 is we interchange the x and y. So we just flip them. So whenever we have an x, we put a y. Wherever we have a y, we put an x. And then we solve for y. So that's the tricky part, can be the tricky part. The first example I'll show you will be pretty basic, and you're like, okay, that sounds pretty easy. What students do is they jump to conclusion that, oh, we just switch signs around, and that's not always the case. So I'll make sure I do a couple examples of that. Then the last one is replace the y with f of negative 1x, so f inverse x, and then you're done. The number 5 rule that I don't have up there is we verify that f and f negative 1 are inverse functions of each other by showing that the domain of f is equal to the range of f negative 1, and the range of f is equal to the domain of f negative 1. So basically they're saying, oh, when you're done, do like the first set of notes at the very bottom. I had it, f of f negative 1 x equals x. Basically just do that, and make sure that they do verify. I'm going to show you some tricks based off that you don't need to do that. I just say, hey, if you do 2 and 3, if you have 2 functions and you do 2 and 3, that make sure the one function matches up with the other function, then you're good to go. So, again, here's the second part of notes. We'll come back, we're going to do a couple examples. And I don't do many examples, but there'll be enough to get you by on terms of what you need to do. So, I'll be right back. Alright, so I'm going to do 4 examples total. Here's the first 3 examples, 10, 11, and 12. So what we need to do, the instructions say on this one, find the inverse function of f. It says informally and then verify, so basically just find the inverse function. That's basically what it is. So if we're starting with 10, and I try to, I know they're basic, they can be basic. If you get it, great, but I show the steps in case, that way you have practice and you kind of get the mindset of what you need to do. So the first thing is, replace f of x with y. That was the first step, okay? Now, interchange the y and x. So like if you're taking notes and you're watching this, I would say, okay, make sure just switch the f of x right on the side of it while we're doing that, and then interchange the x and y, and then solve for y. So those are the notes you need to have next to these things. All you need to do to solve for y, you move the 4 over, so we're going to add the 4 to both sides. We get x plus 4 equals y. The last step is replace the y with f negative 1x. So, f negative 1, x equals x plus 4, and this problem's done. Okay. I know, it's just like, oh, you just change the signs. That's the mindset of it. I want to show you that's not always the case. So, here comes our number 11. First thing, switch the f of x with y. Okay, so we do that. Then switch the y and x again. Alright, so now this one is a little bit different. So what you're going to do, we want to get y by itself. Most students, they automatically just divide by 3. That's the wrong thing to do. Because if you do that, you have to make sure you divide this 1. What proper thing to do is to get y by itself, including the 3y. So I'm going to move the 1 over. Okay, now we can divide by 3. And when we divide by 3, make sure we divide everything by 3, so we get this. The last step is to replace the y with f negative 1x. So, and there's our final answer. See, we did switch the minus and plus sign. The division can be tricky, and that's why I want to make sure do not get in the habit of just switching signs and calling it good. Our last example is number 12, at least for this set of problems. So we have y equals x minus 1 over 5. Okay, switch the y and x. I need to move the 5 over because everything's being divided by 5, so we're going to multiply everything by 5. So we get 5x equals 1 minus, or equals y minus 1. Add the 1 over. Get 5x plus 1 equals y, and finally switch it out. And there we go. So those are some basic examples, and for the most part, if you do this with all the problems, you should be good to go. I'm going to show one more example. So if you need a pause to write down the notes, exactly what happened up there, do that. But I'm going to show one more example that is something I personally will test you on because it deals with more mathematics stuff. And any kind of assessment outside, like a state assessment or a national assessment, they'll also test you on this next example coming up. So, again, if you need the notes, I'll pause right here, write them down, and then we'll get ready for our next example. Okay, for the last example, we have 34, and it says show that f and g are inverse functions algebraically. So, basically we want to show that the inverse function of f of x is equal to g of x. Or and you could do both. So there's two ways to do it. One is you plug all of g of x into all the x's. I'll do that the second way because I think the easiest way to do it, or the most simplest way, maybe not the easiest, the most simplest way, is to solve this one, find the inverse of f of x, and see if it matches g of x. So if we're going to do that, that means we're going to have it like this. Let's go ahead and substitute our y for f of x, and switch our variables. So we get this. Now this problem is going to get more complicated before it gets simple, and that's where students kind of freak out. So what we're going to do, we need to multiply by y minus 2, so we get it on the other side. Because remember, our whole goal is to solve for y. So we have this mess. We're going to go ahead and distribute the x. So we get xy minus 2x equals y plus 3. What I'm going to do is, we want to get all the y's on one side. Okay? So I'm going to move the xy over. So basically I'm going to get negative 2x equals y minus xy plus 3. Okay, remember we want to get y's by itself, so let's move the 3 over to the other side. So we get that. So now the question is, remember, the whole goal is to get y by itself, so what these have in common? They have a y in common. There's a y here and a y here. So we're going to factor out a y. So we get this. Okay. Now let's divide by the 1 minus x. So now we get negative 2x. Sorry. Negative 2x minus 3 all over 1 minus x equals y. Okay, so we got it. So now this becomes f negative 1 though. And we get this. Let me make sure that's in picture real quick. Sometimes I forget. Okay, so now, this doesn't look like this though. So there's a little puzzle we're going to do here. I want this negative 2x minus 3 to look like this. So I'm going to factor out a negative 1 from there. That's the same thing if I distribute that negative. And I want this 1 minus x to look like x minus 1, so I need to flip the negatives around. And we get that. The negatives cancel. And so for our final answer, we get 2x plus 3 over x minus 1. So as you can see, this is an inverse function. Good, you can see all that. This is an inverse function because this matches this. Okay. So if you need to write this down, again, so I'm going to go through. Let me go through the steps again. We switched f of x with y. Then we interchanged the x's and y's. I multiply by y minus 2, both sides, so I get y minus 2 times x equals y plus 3. Distribute the x. Makes it more complicated, but we have to do that. So we get xy minus 2x equals y plus 3. I want to get y by itself, so I'm going to move the xy to the other side, which is what I did here. And then I'm also going to subtract the 3 to the other side. This step, I notice they have a y in common, so I factor out a y, which gives me y equals y times 1 minus x. Divide by 1 minus x. Interchange the y in f negative 1x. Then the last step is a little math trick to notice the negatives and get it to where they are inverse functions. So I'm going to erase this real quick and I'll show you the other way, the way the book explains.